Good morning, afternoon, or evening. How y'all doing today? Today we're going to wrap up chapter 7 and we're going to deal with our favorite models and word problems involving rational expressions. I want you to remember, please, that the goal of any equation or word problem for that matter, regardless of difficulty, is always the same. Solve for the variable in question by isolating the variable. Okay, we already learned how to solve rational equations last week. So now we're going to turn these into word problems and solve from there. Remember that a ratio is a quotient. This is old school already. A quotient of two quantities and can be written in three forms. A ratio, you can say A to B. You can say A to B with a colon, or the one that's really useful is A to B, but written in a fraction form. Okay? These are the easiest types of rational equations to solve. Remember that a proportion is formed by two equal ratios. When you're solving proportion equations, you're setting up two equal ratios in the form of A to B equals C to D, where A, B, C, and D are terms of the proportion. The terms B and C, this guy, those are called the means. You're going to see this in geometry of the proportion. Those are called the means. And the A and D are called the extremes. So the letters in red are the extremes. The letters circled by the blue are the means. So we're going to start off with the easiest type. They're just going to say solve the proportion. In this particular case, we're going to literally just solve. So you cross multiply. You multiply the extremes and you multiply the means. So I've got 105x equals 315 divided by 105, and x equals 3. Done. Pretty simple, easy, everyone's happy. Okay? Very simple type of problem. Number 2, let's go ahead and put this now into words. Okay? Last summer, Alejandra took a study abroad trip to Italy. When she returned, she examined her credit card bill and found that she spent 159 euros on the digital camera she bought in Venice. The bill stated that $1 US dollar was equal to 0.636416 euros. To the nearest cent, how much did the camera cost in US dollars? What you always want to do in this type of problems, where they give you two different sets of ratios. Sometimes you'll have problems involving money. Sometimes you'll have problems involving scale. Scale is like on a map. When you see on a map, 1 inch equals 50 feet. Okay, that's one proportion. One ratio. Whenever you see a ratio like this, you always want to put same unit to the same unit here. And then the other unit, okay, matched up with the same unit on the other side. Now, what am I talking about? The proportion that we know for sure, or rather, I'm sorry, my vocabulary is off. The ratio that we know for sure is that 1 US dollar equals 0.636416 euros. So that is my first ratio. $1 to 0.636416 euros. That we know for sure. That is what I like to call my fact. That's not up for question. That's not up for argument. That is a fact. The fact here is that $1, when she bought this camera, was equal to 0.636416 euros. Now, where does the proportion come in? She paid 159 euros. So unit to unit. If the numerator in my fact had a dollar, then I want dollars on the numerator of the other ratio. The denominator of my fact had euros. So I'm going to put the 159 euros down here. Unit to unit. I want to find out how much did she spend in US dollars. Well, X up here. Unit to unit. So that's what I mean by unit to unit. Now here we have a very simple proportion. So let's go ahead and cross multiply. So I'm going to have 0.636416x equals 159. Divide 159, you may use a calculator, by 0.636416, and that equals, in dollars, because that's what we were looking for, $249.84 when I round it. It's really 0.836, but you round up when you're talking about money. So that's what I mean by unit to unit. Does that make sense? Okay? Please remember that when you're setting up proportions, first set up your fact ratio, the fact, what you know for sure. Then, on your other ratio, set it up unit to unit. For example, scale. This is another big proportion kind of problem. On a map, 1/4 of an inch represents a distance of 15 miles. That is your fact ratio. The fact is that 0.25 inches, you know how to convert 1/4, guys, just divide it. 1/4 inch or 0.25 inches equals 15 miles. Units, label. According to the map, Springfield to Brookhaven are 3.5 inches apart. Find the number of miles between the two cities. Unit to unit. They gave me an actual distance or a map distance here? A map distance, very good. So this is going to be 3.5 inches. Unit to unit over X miles. Unit to unit. Again, this is Mickey Mouse now. Cross multiply. 0.25x equals 3.5 times 15, which I think I did something wrong here. 3.5 times 15, I thought so. 52.5 divided by 0.25, and x will equal, and again, you are allowed to use a calculator here, 210, very excellent, miles. Why miles, Mr. Morrow? Because that's what we were looking for. Okay? Now I know that a lot of you are saying, yeah, but I have a GPS now. That's fine. But the people that made the GPS programmed it using proportions. And sometimes your GPS doesn't work. Sometimes you run out of battery. Sometimes it just breaks. And you're going to need to know how to read a map. You're going to need to know. Sometimes you have to know, do I have enough gas to get from here to there? Okay? Does that make sense? Okay. An automobile manufacturer is advertising special financing on its autos. A buyer will have a monthly payment of $16.67 for every $1,000 borrowed. That is the fact. That's my fact. My fact is you're going to pay $16.67. That's how much you're going to pay for every $1,000 borrowed. So we'll call this BOR. If Mark borrows $14,000, find the monthly payment, unit to unit. What's my payment if I borrowed $14,000? Unit to unit. unit to unit, pay to pay, borrow to borrow. Does that make sense, gentlemen? Okay. We have a long lesson today, so I'm not going to solve this, but that is the setup, and you literally just cross multiply. Okay. And once you do, let me just do the math so when you do it at home, you know you did it correctly. That's exactly correct. Good job. So X will equal $233.38. Again, this is a very good skill to have. You don't want to go and buy a car and be ripped off. You want to be able to know what the payment is. I do that every time I've purchased a car. I've only purchased 3 in my life, but every time I know exactly what the payment is. No one's going to steal money from me. Okay? And I don't do it in my head. I go with my calculator and I set it up, and we go from there. Does that make sense, gentlemen? Awesome. All right. Similar figures. Two figures are what's called similar if the corresponding angle measures are equal and their corresponding sides are proportional. And I am missing one thing here. They have to be the same shape. Similar figures are very easy to solve if you just go, instead of unit to unit, corresponding side to corresponding side. So if I want to find side ED here, okay, I want to find the value of X. Well, the fact is 45 to 10, right? But doesn't 45 correspond to X and 10 correspond to 4? So instead of unit to unit, corresponding side to corresponding side. So this will equal X over 4. Does that make sense? So this would be 180 equals 10x, divide by 10, x equals 18. Absolutely awesome. Good job. Okay? Now, it's going to be used in the real world. Okay? I actually do this all the time, believe it or not, when I'm kayaking. I like to find the height of different mountains that I see, different trees that I see. So I'll do something very similar to this. While hiking in the forest, Joel noticed a bald eagle's nest at the top of a pine tree. If Joel's 3-foot walking stick produces a 4-foot shadow, and the pine tree produces a 24-foot shadow, how tall is the tree? Well, the fact here, is that the 3-foot tall stick produces a 4-foot shadow. Okay? You can draw it out. 3-foot stick produces a 4-foot shadow. This tree, which I have no idea how tall it is, produces a 24-foot shadow. You may say, how can you tell what the shadow is? You can measure that. You can walk it and measure it, estimate it. So I want to find the height of the tree. So height to height, shadow to shadow. So this will be x to 24. Does that make sense? So I believe it's going to be 18 feet. This is going to be 72 equals 4x. Yeah. And x is 18 feet tall. That's how tall the tree is. Does that make sense, gentlemen? Okay, this is the easy part of the lesson. I shouldn't say that. It's all pretty easy, as long as you label things. But is everyone with me so far? Does everyone agree it's pretty simple so far? Unit to unit, unit to unit, unit to unit. Set up your fact ratio, set up your other ratio according to unit. As far as similar figures go, you can draw it out and go corresponding side to corresponding side. But you still are always going to have a fact. They gave you everything that you needed here. That's your fact. Questions, comments, concerns so far before we move on to the real part? We're good? Yes, sir. Well, didn't they say, thank you for asking. The question was, how did I get to 24? The pine tree produced a 24-foot shadow. Isn't this height to shadow? What's the height of the tree to the shadow? No, thank you. Thank you. That's why I asked. Thank you, my brother. Anything else, boys, before we move on? Because now we're going to start cooking. All right. Let's do it. Now, work. Work problems are definitely one of the hardest type of problems. I really never enjoyed doing work problems because I was never really taught a very good way. But I figured out a very good way. And I think, hopefully, that I will be able to transcend this knowledge to you guys in a very simple manner, okay? So as far as work goes, there's a lot of procedures here, but it's all good. It's all good. Okay. Work problem. Remember that when we did distance, we set up a table? Well, we're going to set up a table just like distance. Example 7 says, it's Saturday and Kevin needs to cut and edge the grass. At 9 a.m., Michael asks Kevin to go golfing at 11 a.m. Typically, it takes Kevin 3 hours to cut and edge the grass. When Michael cuts and edges the grass, it takes 4 hours. If they work together, would they be able to finish the lawn and still make the golf date? Okay, so they got to finish the lawn in 2 hours. Step 1, identify what you are solving for. In this case, we want to find how long it will take Michael and Kevin to finish cutting and edging the grass if they work together. You got to think about these logically. Step 2, define the variable you are solving for. Not if this case, but in this case, I apologize. In this case, let x represent the time and hours that it takes to cut and edge the grass while working together. And step 3, write a rational equation using the following logic. Think about it like this. Since Kevin can finish the job in 3 hours, okay, Kevin will finish 1/3 of the job in 1 hour. Michael can finish the job in 4 hours. So Michael will finish 1/4 of the job in 1 hour. Therefore, the part done by Kevin in 1 hour plus the part done by Michael in 1 hour gives you the total work done in 1 hour. When we're looking at work problems, you always want to figure out how much work can be done in 1 hour. And then you can go from there. Yes, sir. Almost. Okay? Pretty much, but watch the way we do it. Just like always, we're going to set up a table. So I've got Michael and I've got Kevin. Michael can finish the work in 4 hours. So his rate, okay, in 1 hour, he can do 1/4 of the job in 1 hour. Kevin can complete the whole job in 3 hours. So he can do 1/3 of the total job in 1 hour, okay? The time here, we don't know how much time it's going to take for us to actually get the work done. So X and X. Why do they both have the same time? Because they are working together. They're going to start at the same time. They're going to finish at the same time. So how much work was done by Michael? Well, he did 1/4 X, because we don't know how many hours. And Kevin works 1/3 X. So the work done by Michael plus the work done by Kevin gives me 1 full complete job. Now, it's simple. Let's go ahead and multiply everything by 12, giving me 3x plus 4x equals 12. Right? We're going to get rid of the denominators. Everyone see that, my brothers? And then this is going to be 7x equals 12 divided by 7. So they can finish the work in 1 hour, 1 and 5/7 of an hour. So if they work together, they will be able to make it on time to go play golf. So this is tough. This is confusing because you have to figure out the rate within 1 hour. And then you have to figure out how much time it's going to take at that rate to complete one full job. Okay? Let's do another one. We're going to do quite a few. John and Sally have a pool in their backyard. If they use their hose alone to fill the pool can be filled in 30 hours. Their neighbor has the same pool and was able to fill it in 24 hours. So I guess they have higher water pressure. Suppose their neighbor agrees to let them use his hose. How long will it take to fill the pool with both hoses? So we got my hose and then the neighbor's. Okay? The rate of the hose that I have in my house, okay, of John and Sally's house, it fills the pool in 30 hours. So how much does it fill in 1 hour? The rate is 1/30th every hour, correct? Because after 30 hours, one full pool was filled. You with me here, guys? I know we're going fast, but I'm trying to make sure you guys understand this. The neighbor's pool, okay, it can fill the pool in 24 hours. So the rate of the neighbor's hose is 1/24th every hour. That means that after 24 hours, it has completed one full pool, one full job. You with me? Okay. Now that we have both hoses working together, we're going to put them on at the same time and we're going to start filling the pool. Do we know how long it's going to take, though? So they're going to both have to work for X hours. How much work was done by each individual hose? Well, X over 30 and X over 24. Again, why? Because rate times time equals work done. Kind of like distance. Rate times time equals distance. But this time we have rate times time equals work done. Does that make sense so far? So, the rate of my hose plus the rate of the neighbor's gives me one complete full job. That's what the goal is here. Okay? The rate of one thing plus the rate of the other thing working together, they're going to give me one full job. I need to figure out, in this case, how much time it's going to take to complete that job. So the common denominator of 30 and 24 is 120. Excellent, son. Why did I put 124? I don't know. So I'm going to distribute to everything here. So I'm going to have 4x plus 5x equals 120. 9x equals 120 divided by 9. X equals 40 over 3, which equals 13 1/3 hours. So using both hoses together, I get the complete job done in 13 1/3 hours. Does this make sense, guys? This type of problem is when you're working together. Okay? This is when you're working together. You feel me? Okay. Number 9. Suppose that the kitchen, why is this? Oh well. Suppose that the kitchen sink can be filled in 5 minutes. If the sink is full and it takes 8 minutes to drain the sink, when the drain is left partially open. If the sink's drain is accidentally left partially open, how long will it take to fill the sink? Well, let's think about this, okay? We have a fill rate and we have a drain rate. Please remember that a drain, when you're draining something, it's negative. You're taking water away, right? It's losing water. So the rate to fill the sink is 5 minutes. So my rate is 1/5 every minute in this particular case because we're talking about minutes. After 5 minutes, 1 full sink is filled. Now the draining, correct, my brother. The drain is really 1/8, but I'm putting it in red here because it's negative. Okay? When it's left partially open, you're losing. You drain the whole entire sink in 8 minutes when it's left partially open. So if I'm filling it and it's accidentally left partially open, the rate of filling is larger than the rate of draining, so you will gain water. But how long is it going to take now to fill that drain? Or that sink, rather? Well, they're both filling and draining at the same time. So how long is it going to take to complete one full job of filling the sink? Well, rate times time equals work done. So x over 5. And the drain rate is negative x over 8. So the rate at which it is filling minus the rate at which it is draining equals one full complete job. And that one full complete job in this case is filling the sink. Go ahead and multiply by 40. Everything. We already know how to do this. So that's 8x minus 5x equals 1. So I have 3, 40. What am I doing? I was going to say, what's wrong with me? Come on, Moro. Pay attention. So I've got, sorry about that. So 3x equals 40 divided by 3. X equals 13 1/3 minutes to fill the sink. Now, some of you guys may think, this is a stupid example. Who cares? What if you're in a restaurant, okay? You're the owner of a restaurant. Water is not free. Water costs money. So if one of your employees accidentally leaves this drain open, it takes almost 3 times as long to fill that sink. That means 3 times as long the water was running. That means the bill's going to increase by that. And when you're an owner, those costs add up. Or let's say you're at home and you needed to fill the sink to do a number of different things. If you leave it partially open, it's going to take that much longer. Okay? So these are valuable things. Are we making sense here, guys? Promise? Okay. Now, uniform motion. It's the same thing that we did before, but now we're going to tweak it. We're going to make it a lot more difficult. I'm sorry. Remember that for uniform motion, my friends, distance equals rate times time. So, for example 10, a plane flies 990 miles into the wind, okay, and makes a return trip following the same flight path. The effect of the wind on the plane is 20 miles per hour. The round trip takes 10 hours. What is the speed of the plane in still air? Okay, this is a really awesome plane. Example. We're going into the wind and, or actually let's just go with and against. Make our lives easy, okay? So you're going against the wind and with the wind, okay? The distance here, all they really give you here is distance, which is 990, both there and back. Okay? And they also tell you that the round trip takes 10 hours. Now, a lot of people are going to say, oh, just put 10 here. No, because that's not the amount of time that it took against. Some people may say, okay, how about this? Put x for time here, and then 10 minus x here. Okay, that's nice if you knew your rate, but do you know your rate? No. So this is where it gets quite fun. I know that my rate, okay, is x. I don't know how fast I'm going. However, against the wind, I know that it's x minus 20. I know that with the wind, it's x plus 20. Now, you may still be saying to yourself, Moro, that's really nice and all, but we're still missing time. Are we really? Remember that rate times time equals distance. So doesn't time really equal distance divided by rate? So the time going against the wind is 990 over x minus 20. No, you do not have to do synthetic division. And the time going with the wind is 990 over x plus 20. Now we use the fact that the round trip took me 10 hours. But before I go there, does everyone see what I did here? You promise? Okay, my brothers. So now, here's where the math comes in. I've got 990 over x minus 20. That's the time it took against the wind. Plus 990 over x plus 20. That's the time it took with the wind. Equals a total round trip of 10 hours. Does everyone see that? Now we have rational equations. Let's go ahead and multiply. Actually, let me just move this here. Let me move this up. Okay, so now we're going to multiply by the least common denominator, which is x minus 20 times x plus 20. When we multiply x minus 20 times x plus 20, the x minus 20 goes bye-bye, and I'm left with 990 times x plus 20. Plus, when I multiply the LCD to my next fraction, the x plus 20 goes bye-bye, and I'm left with 990 times x minus 20. And that is going to equal, my friends, let's see if we have our skills working well. What's x minus 20 times x plus 20? Very good. It's x squared minus 40. Minus 400. That's a difference of squares. So I've got 10 times x squared minus 400. Do you have to do that in your head? No. But that's why it's good to know how to do it in your head. Now let's just do some math. We've got 990x plus 19,800 equals 990x minus 19,800 equals 10x squared minus 4,000. If you notice here, and why did I put 2 equals? What is wrong with me? That's not an equal. Come on, Mr. Morrow. Live in the now. Okay. So 19,800 minus 19,800, that cancels out. 990 plus 990x gives me 1,980x. Okay, you with me here? And that equals 10x squared minus 4,000. Let me drop the next problem down so we could have more room. Okay. So everyone's with me so far? Let's go ahead and make a trinomial here. I'm going to subtract the 1980 to both sides. So I've got 10x squared minus 1980 x minus 4,000 equals x equals 0. Divide everything by 10. Giving me x squared minus 198x minus 400 equals 0. And now, believe it or not, this is pretty easy to factor. What times what is negative 200, but when added together it's negative 198? Excellent. Negative 200 and positive 2. So using my zero product property, x will equal 200 or negative 2. But can I go a speed of negative 2? No, that's impossible, right? So that goes bye-bye. So what is the rate of my plane? 200 miles per hour. Does that make sense, gentlemen? We're good? Okay. We got 3 more to wrap this up. And then remember, guys, you can watch this at home 50 times if you have to. Okay. To prepare for a marathon run, Carlos ran 18 miles before he blistered his heel. And then he walked 1 additional mile. His running speed was 12 times as fast as his walking speed. He was running and walking for 5 hours. Find Carlos's running speed. Okay. So we have a running speed and we have a walking speed. Okay. The total distance that he ran for was 18 miles. The total distance he walked for was 1 mile. That just comes from the problem. Now, his running speed was 12 times as fast as his walking speed. So his walking speed is x. His running speed is 12x because it's 12 times as fast. Now, again, we come to the same problem. Moral, what about the time? No worries, man. Remember that time, rate times time equals distance. So time equals distance over rate. So the time that he ran was 18 over 12x. The time that he walked was 1 over x. His running rate plus his walking rate was completed in 5 hours. So now, let's multiply by the LCD, which is 12x, giving me 18 plus 12 equals 60x. This is 30 equals 60x divided by 60. So x equals half a mile per hour. So find Carlos's running speed. What is his running speed then, guys? Yeah, 1/2 times 12 is 6 miles per hour. This takes time to master. So we're going to go over it in detail tomorrow as well. But you really need to focus on these. And the key here is understanding that time equals distance divided by rate. Now, let's go back to some more work problems, but a little bit different. Let's change it up a little bit. Oh, we already did that one. Okay. Working together, Paul and Danny can pick 40 bushels of apples in 4.95 hours. Had he done it alone, it would have taken Danny 9 hours. Find how long it would take Paul to do it alone. Okay, here's the beauty of this one. Okay, we have Paul and we have Danny. We know that Danny's rate alone, had he done it alone, he would have done 1/9 of the job in 1 hour. But we're trying to find how long it would take Paul to complete it alone. Well, that's going to be 1x, because we don't know his rate. So he's going to do 1/x of the job in 1 hour, because we have no idea what his rate is. Now, the time that it took for them to do it together was 4.95 hours. What was the work done? Well, the work done here was 4.95 over x, and this was 4.95 over 9. I want to find how long it takes Paul to do it alone. Well, the work that Paul did was 4.95 over x plus the work that Danny did was 4.95 over 9 to complete one full job. Now in this case, you multiply everything by 9x. You guys can do that at home. You can solve it. Your answer will be 11 hours. I'm not too worried about you solving in this case. I'm more worried about you setting it up. So in this case, the key here was I was finding an individual rate. So I did not know what Paul's individual rate was. Okay? Go ahead and finish this one up at home, and you should get 11 hours. And last but not least, the last type of work problem. One teacher grades a stack of papers in 8 hours. Another teacher of the same course grades the same size stack of paper in 6 hours. They start together, but the first teacher leaves after 2 hours. How long will it take the second teacher to finish? All right, let's make our table. Rate times time equals work done. Okay, teacher 1, teacher 2. Teacher 1 can grade it in 8 hours. So this teacher does 1/8 of the job in an hour. Teacher 2 can grade the stack in 6 hours. So he does 1/6 of the job in 1 hour. Teacher 1 leaves after 2 hours. So this particular teacher worked for 2 hours. Well, hold on, no, let's not talk about that. Yes, he did complete 1/4, but let's not go that route. We got to fill out the table first, but thank you. Teacher 2, though, he worked for the 2 hours together with teacher 1, plus he worked another X hours to complete the job. So the work done by the first teacher, good job on that part, was 1/4. The work done by the second teacher is X plus 2 over 6. So let me just set this up for you. The work done by teacher 1 was 1/4, plus the work done by teacher 2 was X plus 2 over 6. Together they completed one full job. You can solve that very easily, and X equals 2.5. So teacher 2 had to work an additional 2.5 hours. So how long did it take the teacher to finish? It took him or her 4.5 hours. Thank you for an awesome class. I know it was a fast one, but I know you can do it. Thanks again. I hope you learned a lot. Have a great day.